Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 11, Section 1. And in this video, we're going to be taking a look at the different types of 3D solids that you will see throughout Chapter 11. So the first thing you're going to be taking a look at, as you can see, there are 5 different types of prisms up here on the screen. Prisms essentially are an object that has 2 bases. So if we take a look at the triangular prism, the 2 bases are the triangles. Okay, so the prisms are defined or labeled based on according to what shape their base is. So if they have a triangular base, then it's a triangular prism. If there's a pentagonal base, then it's a pentagonal prism, such as what we have right here. So what you do to create a prism is you decide what shape you want your base to be. And like I said before,
Devin Drew to the office, please. Devin Drew to the office.
Prisms have 2 bases. So you're actually going to, if you're going to start with, like, for example, if you're going to use a triangle as your base, you're going to need 2 of them that are the same size. One goes on bottom, one goes on top. And then those 2 bases, those 2 triangles, for example, are connected at their vertices, or in other words, the corners. So you can see here in the top triangle that the bottom left corner of this triangle, of the top triangle, is connected through this edge, or this line here, to the bottom left corner of the bottom triangle. So, and you're going to see that every corner of every of both the triangles are connected. So the bottom right corners are connected here, and the top corners are connected here by this dotted line. And what you're also going to notice about all of the prisms is when you connect those vertices of the 2 bases, it creates a middle area known as the lateral area. This middle area is known as the lateral area. And each surface or face of that lateral area is a rectangle. Okay? And if we take a look at the other prisms, you're going to notice that same thing occurring. When we take a look at the lateral area, the surfaces or the faces that are created are all rectangles. So prisms are essentially made up of 2 shapes: the shape of their base and rectangles. The rectangles are always going around the lateral area. They wrap around the middle of the object, and the bases are at the top and the bottom of the object. And so the base of an object is typically a face or surface that you can lay the object down on and have it sit upright. And so in this case, we have a hexagon as our base. So you can see the hexagon at the bottom and the hexagon at the top. And each corner or vertice of the hexagon is connected. And when you connect those vertices, it creates rectangles in the lateral area or the middle of the 3D solid. So that's what a prism is. Now, pyramids are very similar to a prism, as they also have a base that changes shape. And that shape can be any 2D shape that exists. So you can have rectangular pyramids, as we do here. You know, a triangular pyramid, as we do here. And what's not shown here is you can also have like octagonal pyramids. You can have hexagonal pyramids and pentagonal pyramids. And it just keeps going. You can have any 2D shape as your base. And then each of the vertices, since there's only one base, they aren't connected to another vertex like they were on the prisms. They actually, all the vertices of the base actually rise up and meet at a specific point above the pyramid. And that point is usually perpendicular to the center of the base. So right here would be the center of the base, and the point where all the vertices meet is a straight line. It is right above the center of that base. So when I say perpendicular, I mean if I drew a line from the center of the base to the point where all the vertices meet, it would be a perfectly straight line. So the point where all the vertices meet is right above the center of the base. And if you were to measure the height of a pyramid, you would actually measure that distance from that point at the top of the pyramid down to the center of the pyramid, and that would represent the height of your pyramid. So a pyramid, like I said, it's very similar to a prism in that it has a base that can change shape and size. But the difference is the pyramid only has one base instead of two. And you're actually going to find out when we get into volume of prisms and pyramids that the volume formulas in pyramids and prisms themselves are actually very closely related to one another. But again, we'll get into that when we get into volume. So the other type of shape that we have two other types of shapes we're going to be dealing with, or two types of figures we're going to be dealing with. The next one I want to talk about is kind of similar to the pyramid, and it's called a cone, and most of us have experiences with cones. But the difference between a cone and a pyramid is a cone's base is not it's not a shape with sides. The cone's base is a circle, so you don't have vertices connecting at a point. So because the circle has no sides, it has no edges, it has no corners, it has no vertices. So the whole circle itself, as the cone rises, as we go up the cone, the whole circle itself is just slowly shrinking as you go up until it reaches the apex, or the top of the cone, where it just becomes a singular point. And so the lateral area of a cone is actually rounded. It's a rounded area, whereas the prism, the lateral area was made of a bunch of surfaces, a bunch of rectangular surfaces. And the pyramid, the lateral area, the area around the pyramid, was actually made up of a bunch of triangular surfaces. But the cone, since there are no edges or vertices on the circle, as you create the lateral area, it's actually a rounded surface. So it's a very smooth, rounded surface. Instead of having a shape for a surface, it's a rounded surface in the lateral area. Similarly to the cone, the cylinder, this is the last of the different figures we're going to be studying in chapter 11. Similar to a cone, the lateral area of a cylinder is also rounded. However, different from a cone, the cone only had one base. Okay, the cone only had one circular base, just like the pyramid only had one base. The cone only had one base, but the cylinder is more akin to, or it's more similar to, the prism in the fact that it has two bases. The prisms have two bases, and the cylinders have two bases. The cylinders, though, have two circular bases, meaning that their lateral area is going to be rounded instead of having rectangular surfaces or triangular surfaces around the lateral area. The cylinder is actually going to have, again, it's going to be a rounded lateral area, which that area, well, the cylinder is very, it is a can, basically, is what most of us see it as. But when we get into the surface area formula for that lateral area, you'll actually discover that lateral area, while rounded, actually is just a rectangle. It's just a rectangle that's been folded around the cylinder. But we'll talk more about that in the surface area sections. So just to recap real quick, we have prisms. They have two bases, and each of their vertices is connected with an edge or a line. We have a cone, which only has one singular base instead of two bases, and that base is a circle. We have a pyramid whose bases can change shape and size, but only have one base instead of two. And finally, we have a cylinder, which has two bases with a rounded lateral area. So we have cylinders, we have pyramids, we have cones, and we have prisms. that come in all sorts of shapes and sizes. So that's it for this section. So tune in for the next video.